Hello viewers, Centroid and Centre of Mass question 2, and we have the centroid that you see on screen here. We need to find its centroid in two different ways. Firstly, by evaluating it as being made of 4 rectangles. So that's what we'll do in this video, and then next video, part B, will be to evaluate it as being made of a large rectangle with a rectangular hole. So we're going to divide the shape up into 4 smaller rectangles. So along the top here is our first rectangle. Then we've got a second one here. So this will be rectangle 2. Then down here we have rectangle 3. And on the right here we have rectangle 4. So we've got the shape made up of 4 smaller rectangles, and notice that none of those rectangles include the hole, so we won't need to subtract that hole for this video. We'll need to do that when we do it the second way, but not for the first way. Okay, so let's draw up our table. So we've got our laminae, which are going to be our 4 rectangles. So the first rectangle is going to have dimensions of height of 0.4 of a metre, 40 centimetres, and it's the whole length long, so it's 3 metres long. So that makes its area is 0.4 times 3 is 1.2. We need to find out where its centre is in the x-bar direction. Well, it's 3 metres long. Our origin is going to be in this bottom left corner. So x-bar here will be 1.5 metres. Then we've got a times x-bar, which is 1.2 times 1.5 is 1.8. We need to find y-bar. So where is its vertical centre? So that's going to be half of 40 centimetres here is 20 centimetres, so that's 0.2 of a metre. And then we need to add on the 1 metre below, so y bar is going to be 1.2, and then a times y bar is 1.2 times 1.2 is 1.44. Incidentally, even though it is symmetric in the y bar direction, we've got 0.4 of a metre below the hole and 0.4 of a metre above the hole. We could make the symmetry argument, but we're not going to. Now, so this was rectangle 1. For rectangle 2, which has the dimensions are, for this one, the dimensions are, we've got 1.5 metres wide and 1 metre high. So its area is 1.5 times 1 is 1.5, and half of 1.5 is 0.75. That's where its horizontal centre is going to be. So we've got 1.5 times 0.75 giving you 1.125, and the y bar is half of 1 metre, is half a metre is 0.5 of a metre, and a times y bar here is going to be 1.5 times 0.5 is 0.75. Now rectangle 3, which is that small little thing in the lower right, which has a height of 0.4 of a metre, and it is, so the whole thing's 3 metres long. This one took up 1.5 metres, so this one must be 1.5 metres wide. So it's 1.5 metres times 0.4 of a metre is 0.6 metres. So its horizontal centre is half of 1.5 is 0.75 plus, so 0.7, so we're looking for where that position is. So we know this is 0.75. This was 1.5, so 0.75 plus 1.5 gives you 2.25. And we've got 0.6 times 2.25 is 1.35. So this is 40 centimetres high. Half of that is 0.2. We don't need to add anything to that 0.2 because this is along the bottom of the shape. and A times Y bar here is 0.6 times 0.2 is 0.12. So that was rectangle 3. For rectangle 4 we've got this little thing here, which is going to be, this is 0.6 of a metre. So it's 0.6 of a metre high and half a metre wide. So this is 0.6 times 0.5, giving you 0.3. X bar here is going to be, easiest thing to do would be half of 50 centimetres is 25 centimetres going back from the right hand end. So 3 metres minus 25 centimetres, 3 metres minus 0.25 metres is 2.75 metres, and multiplying these two gives you 0.825. Now Y bar is, so the centre of this one is going to be, it's 0.6 of a metre high, half of that is 0.3 plus 0.4 giving you 0.7, and we've got 0.3 times 0.7 is 0.21. So that's the 4 rectangles. Now we need to deal with our totals. So 1.5 plus 1.2 plus 0.6 plus 0.3 is 3.6. Don't need X bar or Y bar totals. A times X bar will be 1.8 plus 1.125 plus 1.35 plus 0.825 giving us 5.1, and for our AY bar we've got 1.44 plus 0.75 plus 0.12 plus 0.21 giving us 2.52. So your X bar, overall X coordinate of the centroid, is A times X bar over sum of the areas. So sum of AX bar was 5.1 over 3.6, giving us 1.42, and Y bar is similarly sum of the AY bars divided by sum of the areas, giving us 2.52 divided by 3.6, which is 0.7. So the centroid in metres is X bar Y bar is 1.42 and is 0.7, which we are not surprised by that 0.7 because we did make the observation in passing earlier that it is vertically symmetric because of the location of that hole. You've got 0.4 of a metre below it, 0.4 of a metre above it. So that 0.7 certainly makes sense, and more of that hole is on the right hand part of the laminar, so you've got more mass taken out of the right than out of the left, which has moved the centroid towards the left. If that hole wasn't there, X bar would be 1.5, but because we've taken more of the mass out of that right hand end than the left hand end, the left is therefore heavier and the position of the centroid has shifted to the left. Thanks for watching. Over and out.